Welcome to the 4-hour webinar, Bridging the Gap Between Predictive and Prescriptive Analytics. This presentation will be about 30 minutes long, including a question and answer session at the end. During the presentation, if you do have questions, please type them into the chat feature on the right-hand side of your screen. A recording of this webinar will be available on our website, 4rsystems.com, following the presentation. And now I will hand it over to Jim Van Dusen, Director of Analytics at 4R. Jim?
Thank you, Jessica. I'm Jim Van Dusen. I work with 4R Systems as Director of Analytics. I've been working in retail data analytics and supply chain optimization for almost 2 decades. I'm intimately familiar with all things data science, machine learning, stochastic optimization, and other methods that are helping retailers improve their decision-making throughout their supply chains. In recent years, there's been a lot of attention paid to various aspects of predictive analytics. I'm sure you've heard the use of machine learning, artificial intelligence in pursuit of more refined and accurate forecasts. More powerful and less expensive computational resources, as well as the development of easy-to-use tools, has substantially improved the ability to utilize these methods. This has been incredibly useful in surgically identifying more unique behaviors at more and more granular levels. But today I'm going to talk about a few challenges that are important to consider when actually putting money on the line and making decisions throughout your supply chain. First, and this may seem obvious, but not accounting for the direct financial impact of decisions can be a big missed opportunity. Chasing various competing KPIs can lead to a trial and error oscillating approach that is pretty inefficient. Next, not having a fast, repeatable, quantitative method for making decisions can make it difficult to make all the millions of decisions that are necessary to run your supply chain. And that can also make it difficult to adapt to changing circumstances. And finally, making decisions in isolation without considering how other decisions throughout the supply chain are affecting those can lead to inventory issues that end up cascading through the system. Shortages, excess inventory, sometimes both for the same products if the timing is incorrect. So first, I want to briefly review how analytics are used in the decision-making process. We have descriptive analytics, which help explain what has happened. We're making observations. Then we are using those observations to help predict what will happen in the future. Once we have a prediction of what will happen in the future, then we can use those predictions to help make decisions that lead to a positive financial outcome. And then those predictions and decisions are then compared to what actually happened later on to see how did that actually turn out. So let's briefly go into descriptive analytics. And as I mentioned, these are summaries of the data, observations about what has happened. Sometimes these are used to evaluate other previous decisions, or sometimes they're used to just evaluate what has happened in terms of demand and so forth. And usually this involves looking at various KPIs to determine how the supply chain has performed. We have sales, we have inventory, sometimes we have combined metrics that help us evaluate how efficient that is. Are sales tracking according to expectations? Is inventory building appropriately for an upcoming seasonal peak? Those are the types of things that we're looking to address with descriptive analytics. Then we move on to predictive analytics. And as the name suggests, we're trying to create accurate predictions of what will happen. And this is the part of the decision-making process where machine learning and artificial intelligence methods are often employed, usually supervised methods like regressions, neural networks, decision trees, and so on. Supervised merely means that we're using some historical metric, sometimes demand, and using other characteristics to help explain that metric. Then we use those characteristics looking forward to help us predict what will happen, possibly under changing circumstances or similar circumstances. So, we might be estimating how seasonality differs during different times of the year, how demand reacts to changes in price, and many other predictions that can be made. And this leads us into our prescriptive analytics. These are the decisions that we're trying to make to help improve the bottom line. How many units should we order when we're replenishing stores from our distribution centers? What should the composition of orders be from our vendors? How can we determine what the optimal shipment frequency is to our stores? Should it be daily? Should it be twice a week? All of those are decisions that are made using our predictive analytics, but applying some additional factors as well. So in order to explain how this process works, I wanted to walk through a simple example of an optimization. So let's, for a minute, just assume that we have a store that's maybe a little corner store, and we're trying to decide how many turkey lunches to put in the cooler for the day. And based on our historical analysis, we've estimated that with the cost of ingredients and the labor, that the cost of making a sandwich is about $4. And we sell that to customers for $10 when they come in to buy it. But at the end of the day, because this is the product that has a bit of an expiration date at the end of the day, we have to mark it down pretty heavily and sell it for $3 each, because it's actually at a bit of a loss. But we want to recoup some money from that investment. So now we need to evaluate what is the impact of a decision. Well, let's say that we make 3 of those lunches. That's going to cost us $12. Now there are different outcomes that can happen. What if nobody comes in? We sell none at full price. We have to sell all 3 at 70% off, and we actually lose $3. That's not an ideal outcome. If one customer comes in, we'll sell that 1 at full price, but we still have 2 to sell at 70% off. That's a $4 profit. That's better, but obviously we'd like to sell all of our product at full price. That would be when 3 or 4 customers come in and we get an $18 profit. So those are the different outcomes, but we know that a lot of these outcomes are not equally likely. So we need to consider the likelihood of those. So here I have a chart where, well, first of all, we look at the likelihood of different demand levels. It's more likely that we're going to observe no demand, and very unlikely that we're going to observe 4 units of demand. So what I've done on the right is expanded the height to represent the likelihood to be proportional to that. So we see that the height of demand for 4 units is much smaller, and the height for demand for 0 units is much higher. So now this gives us a better perspective of what is the average. Well, when we weight the profits by the probability of those, we actually get an average profit of $5.05. So this is the expected economic benefit from making this decision to produce 3 lunches. But that's just one decision. Now we have to evaluate multiple decisions. So in this case, we evaluate what's the profit from making 1, 2, 3, or 4 lunches. And it turns out in this case that producing 4 lunches, while there's more upside in that we could get $24 in profit, that scenario is pretty unlikely. And we actually introduce more costs when we observe fewer than 4 units of demand. So overall, even though we have more revenue, the profit, because we have introduced additional cost for 4 lunches, is actually lower. And the best case here is to produce 3 lunches, because it gives us slightly more profit than producing 2 lunches. Now, this is under a very specific scenario, but what if something changes, like the cost? Let's say now we estimate the cost to be $5 because of increased labor or cost of ingredients. Well, now nothing else has changed. The demand for the product is still the same, but every unit, every lunch that we actually put in the cooler costs us an extra $1. So when we buy one lunch, when we make one lunch, it's going to cost us $1 more. So therefore the profit falls by $1. We see the difference between the $3.55 and the $2.55. When we produce 4 lunches, the profit actually falls by $4. And so even though the profits are, of course, all the profits fall, but also we notice that the best scenario for us is to buy or produce 2 lunches instead of 3. So the changing cost causes us to make different decisions, even though the demand for the product is still the same. So, here I've mentioned a few factors that have contributed to making different decisions, but there are many factors that we need to consider. This was just a simple example. And I've broken those down into several different areas. First, we have the consumer demand characteristics. This is one that didn't change between the 2 scenarios, but we did look at the likelihood of different levels of demand. For example, we showed that demand for 0, for no units, was higher than the demand for all other units, especially 4. So we've accounted for that. Another thing to keep in mind is that there may be transaction quantities that are different for different products. For example, if you're considering setting inventory levels for dinner plates, you'll often see demand for 4 units or 8 units of those dinner plates, but 3 and 5 are a little less common. Similarly with tires, a customer coming in to replace a blown out tire might buy just 1 tire, or they might buy 2 or 4 as part of their maintenance schedule. However, it's pretty unlikely that you're going to observe demand for 3 tires in one transaction. And that kind of distribution of transaction size can be pretty important when setting inventory levels. The next group is product characteristics. We considered the wholesale cost of $4 and the retail price of $10 for the sandwich. We also considered shelf life, and that effectively it can only sit on the shelf for 1 day, and then we have to sell it off, or we'll end up scrapping it. But there are some other factors like case packs and pre-packs. If we have to ship in multiples of 24 for something that only sells a couple of units a week, we're probably going to wait until our inventory is much lower before we reorder. If we could buy a single unit, we might order much sooner. And pre-packs, of course, are very different in that they consider multiple products at the same time. So if we're creating excess in some products in order to get back to desired inventory levels in another product, it changes the calculus a bit. Then we have supply chain characteristics. Obviously, lead time is going to contribute to how we set inventory levels. The longer the lead time, not only is inventory going to be depleted more before we receive an order that we place, but there's more uncertainty. And delivery frequency, of course, if we know that we have to wait to order 1 week, we're going to make a different decision than if we know we can order again tomorrow. The next bucket is what I call business constraints, and one of those is the opportunity cost of investing in something where we're just tying up capital and inventory. And this is the cost of carrying inventory, which might be set at 15 or 20% depending on the particular business. That number can and should be used when setting inventory levels, especially when considering the entire assortment of products. And then any vendor minimum constraints should be considered. Much like pre-packs, we're ordering many different products at the same time, and if we have to order an additional $5,000 worth of product, we might make a very different decision and potentially defer that order until the next order cycle because of the excess inventory that it would create. And then the final area is what I refer to as other decisions, decisions that we're going to make in the future about how we flow inventory into our stores and distribution centers, should impact how we behave today. If we know that we're going to ramp up later, there's no reason to bring that inventory in now. Similarly, if we know that there are inventory issues upstream, we may be a little bit more conservative in doling out inventory to the stores. If our distribution center is short on inventory, we will hold it back to allocate it to periods that are stores and time periods that have greater demand. And finally, any decisions that we make about changing the price of an item, of course, will affect demand and then therefore affect how we make decisions about setting inventory. So these are many different ways in which, or many different factors in which we should consider when we're making decisions throughout the supply chain. And all of these decisions are interrelated. As I mentioned, changing the price affects demand, which affects inventory levels. Decisions about future decisions about how we'll be supplying the stores will affect how we should position inventory in our distribution centers. And all of that contributes to the inventory flow, both into the stores or into and out of the distribution center. And that will have a big effect on our workforce planning. If we see that there's going to be an influx of inventory in November at our distribution center, we can make decisions in one of two ways. We could say, we need to ramp up our workforce, or if we can't do that, we may start to flow in inventory sooner than November in order to smooth that out so that our workforce can accommodate the flow of inventory. So these are all the different ways in which various factors throughout the supply chain can affect how we make decisions. And so the key takeaways here, and this is going back to those challenges that I mentioned, is that first, we should always consider the financial value of the decisions that we're making so that we're always contributing positively to the bottom line and not just chasing some key performance indicators that may not directly address profitability. The second thing is that we should establish comprehensive, adaptable methods so that we can quickly make decisions and be able to evaluate various what-if scenarios if certain characteristics of the supply chain or products changes over time. This allows us to react much more quickly and to run quite a bit leaner in many instances. And finally, it's imperative that we take a much higher level look at the impact of our decisions when we're making them. Even though they could be made in a silo, it's much better to treat them as also affecting other decisions and evaluating the impact of that on all of our decisions throughout the supply chain. So those are the key takeaways. And at this point, I'd like to open it up to any questions that people might have and address those.
Okay, if you have questions at this time, please type them in the chat feature on the right-hand side. We do have one question come in. It says, how has COVID affected the predictive analytics process?
Yeah, that has definitely been a challenge during the last couple of years. We all remember the shortage in toilet paper in March of 2020 and the inability to get that for several weeks. And that was a problem for many different products. And the tendency in these cases is to often think that, well, this is so unrepresentative of what might happen that maybe it's best to just ignore that data when planning for the future. And while that may be the case that it's not very representative, it does serve as somewhat of a warning that maybe the uncertainty in the world is greater than what we had been assuming. And by considering the additional uncertainty, we can make many different decisions that help us mitigate the I don't know, costs associated with these types of disruptions. So for example, we could identify multiple vendors that have the same product, or maybe have a greater assortment of products to help avoid inventory shortages when these types of disruptions occur. That's one way in which we can do that. Other ways is just supplying greater levels of inventory in products that might be susceptible to these types of disruptions. So yeah, I think that's a very important question to address.
Thank you. We have one more question come in that says, you talked in the presentation about being profit optimal. Is it necessary to be profit optimal for every item in your store?
I mean, this is actually a very good question, and sometimes it's the answer is kind of yes and no. But when looking at an individual product in isolation, no, it's not necessarily important to be profitable on that item. There may be many items that are traffic drivers that aren't necessarily all that profitable, and in some cases might take a little bit of a loss, but that's only when looking at it in isolation. When we consider the fact that those items that are generating traffic are prodding people to buy other products, then they really are generating additional margin and profit from those other items. So when you look at the system as a whole with these traffic driving low margin items, as well as the other items that are being purchased, you see that having those low margin items actually contributes positively to total profitability across all the products. So it's not important to be profitable on every item in isolation, but it is important to be profitable when considering all the items as a whole.
Thank you, Jim, and everyone for your time. This concludes our presentation. A recording of this webinar will soon be available on our website. So thank you everyone for attending and have a great day.
All right, thank you.